The primary flight display, PFD, displays all the normal primary flight indications: attitude, airspeed, altitude, vertical speed, heading and track. The green diamond represents track. Notice that the indicators are laid out in a classic instrument T configuration. The PFD also displays other information. The upper part of the display is used to provide information to the pilots associated with the Flight Management and Guidance System, FMGS. The area is known as the Flight Mode Annunciator, FMA. A Flight Director push button on the EFIS control panel enables the pilots to switch the Flight Director display on. Notice that there is an indication on the FMA when the flight directors are switched on. Caution: both flight directors must be switched on or both off. You should never fly with only one flight director selected on. When below 2,500 feet, a digital radio altimeter is displayed. In this module, we will concentrate on the primary flight indications. Let's start with attitude. Attitude information is shown at the center of the display. The attitude indicator is conventional. The aircraft is represented by 3 black and yellow symbols which remain fixed. There is a graduated scale for pitch angle above and below the horizon. Bank angle is displayed at the top of the indicator. Each graduation represents 10 degrees angle of bank. The roll index triangle moves against a fixed scale to show angle of bank. To show both the pitch and bank indications in use, let's look at the indication for a climbing turn. In this example, the aircraft is in a 20-degree bank turn to the left with the nose-up pitch attitude of 10 degrees. Below the roll index is the side slip index. This index moves to indicate side slip and replaces the old-fashioned slip ball. When the Flight Director push button on the EFIS control panel is selected, Flight Director indications are superimposed onto the attitude indicator. In the example shown, the Flight Director is centralized. The vertical line is the Flight Director roll bar, while the horizontal line is the pitch bar. Let's look at an example of the Flight Director in use. In this example, the Flight Director is directing a pitch up and roll to the right. Once the aircraft has achieved the required pitch and bank, the Flight Director bars will once again be centralized. Now let's look at the airspeed indications on the PFD. The speed scale moves behind a fixed yellow reference line and triangle. In the example shown, the indicated airspeed is steady at 250 knots. When the aircraft is accelerating or decelerating, a speed trend arrow appears. This arrow shows the value that will be attained in 10 seconds if the acceleration remains constant. In the example shown, the aircraft will decelerate to 240 knots in 10 seconds. When the Flight Management and Guidance System, FMGS, is controlling the airspeed, a magenta target airspeed triangle appears. This is normally referred to as managed speed. In the example shown, the managed target airspeed is 240 knots, and the aircraft is decelerating toward that speed. If the target airspeed is selected manually, a blue triangle appears. This is normally referred to as selected speed. In the example shown, a selected airspeed of 260 knots has been set, and the aircraft is accelerating toward it. Manual speed selection is achieved by a rotary selector on the FCU panel. Just above the selector is the indication of the selected speed. As a general rule on the PFD, a magenta indication means managed and a blue indication means selected speed. You will see this in the examples that follow. To understand the various other indications on the airspeed scale, we will run through a typical flight profile. We will assume a departure with the flaps in position 3. You will learn about the various flap and slat configurations in the flight control modules. During the takeoff roll, a blue decision speed, V1, and a magenta V2 speed are shown. Notice that since these speeds are beyond the visible scale, they are shown as numbers. As the takeoff progresses, V1 and V2 indications appear on the speed scale as a blue 1 and a magenta triangle. During all takeoffs and go-arounds, the Speed Reference System, SRS, is active. SRS will command an initial climb speed of V2 plus 10, or in case of engine failure, V2 or existing speed. In this instance, note that the managed speed triangle remains at V2, while the actual speed is 10 knots higher. The minimum flap retraction speed is shown by a green F. This is referred to as F speed. The flap limit speed is shown by a red and black strip at the top of the speed scale. At F speed, the flaps are retracted to 1. When the flap handle is placed to 1, the F disappears and is replaced by an S. At S speed, the flaps are retracted to 0. The S disappears, and now the green dot symbol appears. Green dot is defined as the best lift-over drag speed. Note that United Airlines uses a thrust reduction acceleration altitude of 800 feet AGL. At that point, it is UAL policy to clean up and accelerate to green dot. Green dot speed is maintained until 3,000 feet AGL, at which point the aircraft is returned to managed speed and allowed to climb at 250 through 10,000 feet. Above 10,000 feet, the target speed will increase to climb speed. The actual speed will be determined by the cost index number. UAL's policy is to use a cost index of 35, which results in a climb speed of approximately 300 knots. At approximately 25,000 feet, VMO becomes the airspeed equivalent of MMO, Mach 0.82. In this example, the indicated Vmax of 300 knots represents the equivalent of Mach 0.82. Present airspeed is 280 knots, or Mach 0.782. During an FMGS computed or managed descent, the single triangle is split into two to give a speed range. A double magenta bar indicates the target speed. A standard descent speed of cruise Mach with a crossover to indicated speed at 280 knots is inserted into the FMGS and is treated as a managed airspeed. The speed will vary in between the two speed range indicators as the aircraft maintains the required descent profile. Following initial deceleration to 250 knots, we see the symbol for the next flap limiting speed, VFE next. Since the aircraft is clean, the next flap setting is 1, so the symbol appears at 230 knots, which is the maximum speed for extending flaps to 1. The VFE next indication will be visible provided the aircraft is below 15,000 feet. Green dot speed may also be visible. It is UAL policy to slow to a minimum of VFE minus 10 knots before selecting the next flap setting. A further deceleration to green dot speed takes the airspeed below the VFE for the first flap selection. Flap 1 can now be selected. Notice that a target speed of 140 knots has appeared. This represents the approach speed target. Once the flap lever is in position 1, S speed, VFE next, and the flap limit speed indications will appear. If the system is in the managed speed mode, airspeed will automatically decrease to S speed. Notice that at S speed, the aircraft is below the limit speed for the next flap setting, BFE next. Flaps 2 can now be selected. Click on the flap lever. As soon as the flap lever is in position 2, S speed is removed. F speed and a new VFE next indication will appear. The flap limit speed will move to a new limit. Notice that the approach speed target, V approach, has now appeared as a magenta triangle. The aircraft will continue decelerating toward F speed. By reducing toward F speed, the aircraft will be below the VFE for the next flap setting. Flap 3 can now be set. Click on the flap lever. As before, VFE next and VFE move to reflect the new flap position. Flaps full can now be selected. Click on the flap lever. The aircraft will eventually stabilize at V approach, and the VFE will be adjusted to reflect full flaps. There are indications associated with speed and angle of attack protections. These protection indications will be discussed in the flight control modules. Once the aircraft lands, all additional speed indications are removed except for the speed trend arrow. Having thoroughly studied the airspeed indications, let's look at altitude indications. All the indications associated with altitude are located on the right-hand side of the PFD. The main part of the display is dedicated to the altimeter. To the far right is the vertical speed display. We will look at the altimeter indications first. The middle part of the altimeter contains a green digital readout of altitude. The red ribbon to the right of the altitude scale represents the field elevation. The ribbon is currently level with the center of the scale. Like the airspeed indication, a gray analog altitude tape moves behind the digital display. In this example, there is a target altitude of 17,000 feet displayed. On the Flight Control Unit, FCU, there is an altitude selector, which shows the current selected altitude. At the bottom of the altimeter is an indication of baro reference. In the example shown, the QNH is 30.08 inches. The baro reference setting is achieved by a selector with associated indication on the EFIS control panel. The baro reference may be changed from inches of mercury to hectopascals by rotating an outer selector. To look at the various other indications on the altitude and vertical speed scales, we will run through a typical flight profile. The aircraft is on the ground. Notice that with a QNH of 29.92, the altimeter shows 10 feet. The aircraft is airborne. The vertical speed indication is showing a climb of 3,400 feet per minute. The aircraft has now been cleared to flight level 330, so the new target altitude has been set. On passing the transition altitude, the standard pressure setting must be set by pulling the baro reference knob on the EFIS control panel. Notice that the baro reference indication has changed to STD, and the target is now shown as a flight level. The aircraft is now cruising at flight level 370. Notice that the target flight level box is in the middle of the scale, and the vertical speed indication is at 0. At the transition level, the baro reference is set to show QNH by pushing the baro selector knob on the EFIS control panel. In the final stages of an approach, the ground reference ribbon will reappear, along with the landing elevation line. Notice that the vertical speed indication is showing a rate of descent of 800 feet per minute. Also notice that the missed approach altitude has been set at 9,000 feet. When the aircraft lands, the ground reference ribbon is in the middle of the scale and the vertical speed indication is at 0. We will now look at the compass scale. The compass display is very conventional. The gray scale moves against a fixed yellow line, which represents the center line of the aircraft. In the example shown, the aircraft is on a heading of 091 degrees. The small green diamond represents the aircraft track, and it is normally referred to as the track diamond. In the example shown, the track is 094 degrees, which means that the aircraft has 3 degrees of drift to the right. A selected heading may appear either as a blue figure on the appropriate side of the compass scale or a blue triangle. On the FCU, there is a heading selector with an indicator that is linked to the selected heading indication on the PFD compass. There is a direct relationship between the small white ticks on the horizon line of the attitude indicator and the compass scale. As the heading changes, the ticks move to stay in line. Now, let's look at how ILS information is displayed, and in particular concentrate on the compass scale. The ILS switch on the EFIS control panel enables the pilot to switch on an ILS display. The ILS display includes indications for localizer, front course, glide slope, information. ILS deviation information is displayed in the form of localizer and glide slope deviation scales. The ILS front course will be displayed in magenta at the side of the compass scale, if the figure is outside the visible scale. A magenta diamond represents the localizer. When the ILS front course is within the compass scale, it is displayed as a magenta dagger. In the example shown, the aircraft is established on the localizer, and the glide slope indication has appeared in the form of a magenta diamond. The aircraft is now fully established on the ILS approach. Let's look at the indications on the compass scale in detail. With the aircraft established on the localizer, the heading is 230 degrees. The track diamond is showing 3 degrees of left drift. The ILS front course dagger is beneath the track diamond. You will see how useful the track diamond can be to help you fly an accurate approach in the simulator phase. You will be given more information on the ILS system, the flight director, the radio altimeter, and the flight mode annunciator indications later in the course. Now, let's look at another useful indication available on the PFD, the flight path vector. The flight path vector can be displayed on the PFD to show you what the aircraft is doing in relation to the world. It is an indication of the aircraft flight path. It is not a director. The green symbol, sometimes called the bird, represents the aircraft. The attitude indicator represents the world. Let's look at the FPV in a bit more detail. To begin with, we will look at the indication for an aircraft in level flight with no drift. For training purposes, we will exaggerate the angles. The aircraft heading and track are the same, so the flight path vector and the track diamond are in line with the heading marker. These indications mean that the aircraft is not drifting. The aircraft is flying level with the pitch attitude of 9 degrees. The FPV is on the horizon line, so at present the flight path angle is 0. That is, the aircraft is in level flight. Now let's enter a descent and see what happens to the flight path vector. The flight path vector will move down to indicate the angle at which the aircraft is descending through the air. This is known as the flight path angle. Now, let's introduce some drift to the left. As a result of wind from the right, the aircraft is drifting to the left. Let's now look at a typical example of how the FPV indication would look for an aircraft established on an approach. The aircraft is fully established on an ILS approach. Notice that the flight path vector is in line with the track diamond, indicating left drift. The FPV is below the horizon line in a 3-degree descent angle.